go over this. This is quadratic in form. I'm just going to rewrite that first term as e to the x squared minus 9e to the x minus 22 equals 0. I'm going to try to factor that. So in order to get e to the x squared, I'd have to have e to the x and e to the x. So now I'm looking for numbers that multiply to give me 22. 1 and 22, 2 and 11. 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 doesn't work, 10 doesn't work, 11's on the list. Okay, so it's a fairly short list. Okay, they're going to have opposite signs. I want them to subtract to give me 9, so we want the 2 and the 11. Looks like we want the bigger one to be negative, so e to the x minus 11 times e to the x plus 2. Okay, so then I set each factor equal to 0. This would become e to the x equals 11. This would become e to the x equals negative 2. I can reject that because e to the x is never negative. It has to equal something positive. Here, I can take the log of both sides. I can say natural log of e to the x is natural log of 11. So x is the natural log of 11, and that's my one answer. Okay. I could also go right to here because this, if I rewrote that in log form, would simply say that x is the exponent I need when e is the base to get 11. So that, rewritten as a log equation, is my answer. Okay, I'm just going to show you what it would look like if we had used the quadratic formula. My a is the coefficient in front of the squared term, so that would be 1. My b is the coefficient in front of, in this case, the e to the x, the thing that I'm squaring when it's not squared. And my c would be negative 22. Okay. So, then when I use the quadratic formula, most important thing to remember here is that I'm not solving for x. I'm solving for e to the x, because that's the thing we were squaring in this equation. So e to the x would be the opposite of b, plus or minus the square root of b squared, minus 4ac all over 2a. So that would be 9 plus or minus the square root of 9 squared is 81, minus 4 times 1 times negative 22 all over 2. So that's 9 plus or minus the square root of, these two negatives are going to cancel, so that's going to become 88 plus 81, so that's 169 all over 2. 169 is 13 squared, so this is negative 9 plus or minus 13 all over 2. Okay. Now, if you don't have your perfect squareds memorized up to 13, you would just want to check. I can see, should pretty much know your perfect squares up to 12. 12 squared is 144. This is bigger than that. If I want to see if it's a perfect square, I would just try 13 or 14. And see, 14 is too big, but 13 works. Okay. Let's see. So, e to the x is either negative 9 plus 13 over 2, or e to the x is negative 9 minus 13 over 2. Negative 9, I'm sorry, it wasn't a negative 9, it was a positive 9. I miscopied this here. It was a positive 9, I had my equal sign there. So it was 9 plus or minus 13 over 2. Let's fix that. Okay, so 9 plus 13 is going to give me 22 over 2. That would be 11. So we're getting e to the x equals 11. Here, e to the x is equaling 9 minus 13 is negative 4 over 2. We're getting e to the x equals negative 2. Notice, those are the same two things we got by factoring. This has no solution, and this becomes x equals the natural log of 11. So I just wanted to show you that you can use the quadratic formula. I think the factoring is simpler when these things do factor, but it's up to you, and it does work. Just remember that the quadratic formula in this case is giving you e to the x, not giving you directly what x is.